Hello and welcome to How to Build Apps for the Apple Watch, Lesson 2, Learning Swift 2.0. In this lesson, we're going to first understand how Xcode playgrounds work, because we're going to be using playgrounds extensively as we learn the Swift programming language. And number 2, and this is a big one, we're going to understand the Swift 2 programming language and syntax by the time we're finished this lesson. So there's a lot of material in here. It's not to be taken lightly, but I will make this as painless as possible. And in fact, Swift is very easy to learn, so you will find, whether you've coded before or not, that it is actually pretty easy to pick up on. So let's get started. In this video, we're going to learn how to start an Xcode playground. And we'll be doing this throughout the rest of the lesson, so I'm not going to go over this each time we do it. Just know that each time a new video in this lesson occurs, that we're going to be starting with a new playground. So let's jump over to Xcode and see how we start one. So Xcode is open, and we've briefly taken a look at this screen before, and basically this is just the welcome screen. And the first thing that it actually gives you the option to do is to get started with a playground. So what we want to do on each of these videos within this lesson is to go ahead and start a new playground. So we're going to get started with a new playground by clicking it and just move this where it's supposed to be here. So we're going to start the playground, and I'm just going to call this intro because it's not really going to have anything, and click next. And then we save a spot for our playgrounds here. And we just hit create where we want to save it. And our playground comes up. And there we go. So when we start each lesson, there'll be a new playground. And I will have the playground already running so that we're not wasting time each time we do this. But this is the basic playground. As you see, it has first a comment, and then it imports the UI kit, and then it has a variable declared here. And we're going to get into all the details about what all this means and what the left side and the right side does. And in fact, there is a bottom to this as well. So we'll get into what that says. So, or not what it says, but what it's useful for. So we'll see you in the next video. In this video, we're going to start learning Swift, and we're going to open a playground, and we're going to start learning the Swift basic syntax, variables, and constants. So we're going to start right at the beginning here, and we're going to show you the basic syntax. We're going to explain what a variable and a constant is, and we're going to take it from there. So let's jump over into a playground. So we're in our playground, and I first actually want to start talking about the playground. I'm actually using the playground that I created in the last video. So when you open a playground, it automatically has this text in it. And basically the playground works like this. On the left side is where you put your code, and on the right side is what's compiled by the code compiler, and it spits out whatever the value is. So in other words, this is a variable called str, and it's set equal to the value of hello playground, which is a string, and you can tell that's a string because it's in double quotes. Okay, so all it does is it spits out that it's hello playground on the right hand side. Now if we did other things with it, it would show the modified version of it. Like if I were to re-evaluate str and I set str equal to just hello, then you'll see the str on the right hand side now equals hello. And I was able to change that because that's a variable. But just real quick on the big picture, the left side is where we put our code, and the right side is where it's evaluated. Okay. Now, this first line is a comment, and you can tell it's a comment because number one, it's in green, but number two, it starts off with these 2 forward slashes. Now, anything that starts off with 2 forward slashes is going to end up being a comment. So this is a comment. This word variables, constants, semicolons, type declarations, white space, they're all comments, and they are for human readability only. So the code compiler just completely skips that. It says, okay, this is a comment, let's skip ahead, there's nothing there. This is a comment, let's move on. it doesn't do anything with them. Okay, so let's talk about variables for a second. This is a variable. This is maybe the first time you've seen code, or maybe the first time you've seen Swift. So in order to create a variable, we start off with the var keyword. So I'm going to create a new one here. I'm going to say var, and then we give it a name, and this one I'm actually going to call name, and I'm going to say equals, and I'm going to put my name in there. Okay, so the fact that I put my name in between two double quotes means that it's a string. Now, you may be wondering, I didn't declare that it's a string, so how does it know that it's a string? Well, it's pretty obvious that it's a string because it's in double quotes, and Swift uses something called type inference. So if it's brutally obvious that something is of a certain type, then there's no need to specify it. If I were to specify that this was a string, I would say name, and that colon means of the type. I would type in string and then say equals JSON, but notice there's no difference on the way that that gets compiled on the right hand side, so there's no need to type in that type declaration. Okay, it's actually poor form. It's considered poor form if you type in a type declaration and it's brutally obvious what the type declaration is. Okay, so just keep that in mind. Now, as a variable, I can also go down and change the value of that variable. So as I did with str, I can say name equals, and then I'll put my full name in. So name equals Jason Ribka, and now when I pull up name anywhere, so if I just type in name here, it'll evaluate that and it'll put the value of that on the right hand side there. You see how that works? So that is a variable, and variables are meant to be changed. So when you create something that is a variable, that means you're expecting the value of it to change. Now, a name, you don't actually expect to change much, do you? So what you would do is you would set it as a constant. And for constants, that means that they can't change, and use the let keyword in order to declare a constant. So we would say let name2 equal, and we would set that to, I'll say Eric. Okay, so now name2 is Eric. I cannot come down here and say name2 equals John, because you'll see I automatically get an error here, and what this error is saying is change let to var to make it mutable. So it's saying change this let value to a variable value so that we could change it, but we want it to stay Eric because we know Eric doesn't want to change his name to John, so we're just going to leave it that way. Okay, now there are a couple things that you may be wondering. One of them was the type declaration. If you're coming from a different language, is that I at no point did I say that it was a string, but as I showed you above, there's no need to. So if I create a variable and I say that it's age, there's no need for me to say integer equals 40, because 40 is a whole number without a decimal point, so it's definitely an integer. So there's no need for me to say that when I can just say variable age equals 40. So it's kind of redundant, so we don't need to do it. Now, in addition, you may be wondering where the semicolons are. So if I create a variable and I call that school, and I set that equal to Mount Pleasant, for example, and I put the semicolon at the end so I can go to the next line, you'll see on the right hand side, once again, no effect on it at all. And in essence, what the compiler does is it uses end of line characters to go ahead and detect when a line of code has been completed. So basically, the semicolon acts as a period in a lot of different languages to say that, okay, this is the end of the command. But in Swift, there's no need for a semicolon because it uses end of line characters, so we could take that out or leave it in. If you're if you're really, used to leaving it in, then go ahead and use them, but there's really no point in using them because they're not required, and why waste the time to, we're coders, let's face it, we try to do things as simply as we can possibly do them. So, and another thing you may be wondering is about white space. So if I say var dog name equals Mikey, then you might be wondering if there's a problem if I put space here, and indeed there's not. Swift doesn't act like Python in any way. It doesn't use white space as a hierarchy. The only time you need to worry about white space literally is when you're using this assignment operator, which is the equal sign. And if you have a space on one side, then you must have a space on the other side. You see how I'm getting an error here, and the error is because I have a space here and then I have equals Mikey. Now I could do it like this and say dog name equals Mikey, and that would work, but notice how much more readable it is this way. So this is the standard convention. This is how you should do it. And for right now, we're going to leave it at that, and we're going to go into more depth about numbers and how variables and constants operate in the next video. In this video, we're going to talk about number types in Swift, and there's basically three different number types. You have integers, floats, and doubles, and we're going to take a look at all three of those right now. So let's jump over to a playground and we'll do just that. Okay, so we're in our numbers playground here, and we're going to talk about integers, doubles, and floats. Now, one thing that I failed to mention in the last video was this import UI kit and this var str string that pops up there every time. We don't need that, so I'm just going to get rid of that. And I'm just going to leave it at this. So integers are whole numbers. So if I create a variable called a, and I set that equal to 32, then that's an integer, okay? And that's inferred as an integer, okay? Because it's a whole number, has no decimal point. Now, interestingly, doubles have decimal points and floats have decimal points. So when I say variable b equals 32.2, then Swift automatically infers that as a double. Notice that if I say down here variable c, I need to specify that this is a float, otherwise it will think that it's a double. So 32.3 we'll say. Alright, now you don't see a difference in the right hand side. I understand that, but let me show you what the actual difference is between doubles and floats, because the fact that they're made for 64-bit systems or they're made for 32-bit systems really is inconsequential to us if you think about it. And when you're programming, you're not thinking about whether they're on a 64-bit or a 32-bit system. You're really not. So it really doesn't matter. But you will encounter floats when you code, and you will be using doubles when you code. So it's important to actually know the difference. And the difference really is how accurate they are. So doubles are twice as accurate as floats. And when I say that, I mean down to the decimal point. So if we actually need to create different variables here. So I'm going to say variable number 1. And I'm going to set that equal to 32.2. And then I'm going to say variable number 2. I'm going to set that equal to 2.4. And then I'm going to say variable result is equal to number 1 divided by number 2. And then if you look on the right hand side, you'll see how many decimal places that goes over. Now that's a double. Now if I do the same thing, but I specify as floats, so if I create some new variables here, so if I say variable number 3, and I set that, I'm going to set this equal to the same thing, so 32.2, and then I say variable number 4 is equal to 2.4, and notice I have also forgotten to specify that these are going to be floats. So we need to specify that they're going to be floats so we can see a difference here. Otherwise, it's going to think that they're doubles, and we're going to see exactly the same thing. Okay, so then now on variable result 2, we don't need to specify because it's going to be number 3 divided by number 4, which are both floats, so it's going to come out to be a float. So now you see that only goes 5 decimal places over, whereas the double goes about, I don't know how many that is, maybe that's a 12, or I know it goes up to like 15 or 16 depending on how accurate it can actually be. But notice the accuracy is different, where it goes to 4.1667 at the 5th decimal place, whereas result will go much further and give you a much more accurate number or estimation of what that actually is. Okay, so that's the difference between floats and doubles. And why would you use a float versus a double? Well, really you wouldn't, but there's certain parts of programming where you need to use floats because it's so ingrained in the system. So when you need to use a float, you're going to need to specify that it's a float, or a lot of times it will be specified for you and you'll just need to use a float. And the same thing with the integers. So an integer is a whole number, so I can't, this is important, I can't go ahead and then redeclare a and say a equals 8.9, because then that would be a double. Okay, and I can't say that an integer is now a double. And this is what's called type safe and type strict. So once I declare something as an integer, it always has to be an integer. Once I declare something as a float, it always has to be a float. Once I declare something as a double, it always has to be a double. And the same thing goes for a string. I can't set a string to the name of Jason and then say that that string is equal to 45 or 44 or any other number or value, because it just won't work. Once you set a variable, it's set as that same type. Okay, and it has to remain that type throughout the remainder of the program. Okay, all right, so I think that's going to be it for numbers. Now with numbers, if you notice here, I had number 3 divided by number 4. You can use, mathematical symbols the way you normally would. So, I could easily use variables to do this, but if I did 4 plus 3, it'll evaluate on the right hand side and tell me exactly what it is. So you can do all sorts of mathematics. Just use the hyphen. And if you want something done first, so if I wanted to say 4 plus 3 divided by 4, then this would take 3 divided by 4 and then add 4 to it. Now we're not getting a very accurate answer over here, but it is doing the calculation. It's just we don't have the remainder. Okay, so because these are integers, so it's not giving us any remainders. It just gives the float values, the integer value, which is 4, because 4 divided by 3 or 3 divided by 4 is just about 1, and it just doesn't work out so that we get a more accurate number. Okay, but I'm going to show you how to deal with that in a future video when we talk about the modulo operator and things like that. I just won't want to bombard you with things right here at the very beginning of the lesson, so we're going to take it kind of step by step, and as we come across things, I'll explain them a little bit more in depth. Okay, so that's going to be it for this video. I'll see you in the next. Okay, so in this video we're going to start talking about control flow. So in other words, controlling the way our code flows based on the value of something or based on the status of something. So we're going to start off with if-else conditional statements, and we'll move on from there. So let's jump into a playground and tackle these if-else statements. So if-else statements are very common in programming, and they're one method of control flow. So in other words, they're one way to determine the way that your code flows through your program, depending upon the value of one variable, or depending upon the status of something. So we'll create a variable here, and we'll call it temp for temperature, and we're going to set that equal to 32 degrees. Okay, and then we're going to set another variable, and we're going to say variable is freezing, and I'm going to make that a Boolean, and initially I'm going to make that true. Okay, so a Boolean, just to touch on that real quick, a Boolean is either a true or false statement. And yes, this is kind of poor form where I'm declaring that it's a Boolean and setting it to true at the same time, because if I said is freezing equals true, then it's clearly a Boolean. But I just put that there so you know how to declare something a Boolean if you wanted to. Okay, so what we're going to do is we're going to take a look at the if-else statements now, and we're going to basically set the variable is freezing based on what the temperature is. So we're going to say if temp is less than or equal to 32, then we're going to say is freezing is true. And then otherwise, and we could just say else here, or we could say else if temp is greater than 32. That's not greater than, that's greater than 32. Then what we would do is we would set is freezing equal to false. And then just to finish this off, then we're going to say else. So if it can't determine those two, we're just going to do a print line. And the way you do that is you just say print. We'll put a string in here, and we're going to say could not get temperature. Okay, so now you'll see that this if-else statement is already evaluating things. Okay, so basically it says freezing is true over here based on this temperature 32. But if I set this to 36 or 35, then it'll automatically evaluate to false. And if I, well, there's no way for me to set it because I don't have it as an optional. We haven't gone over optional, so I don't want to get into that right now. But basically what it's doing is, if it's less than 32 or equal to 32, then it's going to set is freezing to true, which it's already set to true. But if we had set it to equal a Boolean without setting the value, then we could have done that. But I want to wait until we get to optionals to show that to you. And then if it's over 32, then we're going to set is freezing to false. So right now it's 35, and it's evaluating to false. And if none of those would evaluate, we could actually go ahead and print a line that said could not get temperature. Now we can also, instead of just setting it to is freezing, we could also do a print line here where say it's freezing. Okay, so we'll get that print line going, and then here we would say it's not that cold, we'll say. And you'll see that that also evaluates over there on the right hand side. Now if you look here closely, you're getting this new line character at the end of here. That just happens in a playground. Don't worry about that. That won't happen in your real code. And anything in a print line would just go in your console at any rate anyhow. So that would be down here. So it's saying it's not that cold. This backtrace and everything is just because of the beta, so don't worry about all that. But it's just saying it's not that cold down there because that's what it's evaluating to. Now if I change this to 32 again, or anything under 32 really, then it says it is freezing, and is freezing is set to true. So you see how that works? It's it basically goes off of the variable, and it evaluates it, and if this is true, it runs what's in between these two blocks of code. And then if we have an if statement, then if this is true, it runs what's in here. And if we didn't have this else statement here, then we could have just said else is freezing is false, because it wouldn't be under 32. So we could make it that simple, and that would be, the optimal way to do it, because you don't really need to declare, that if it's 33 or above, you know what I mean? So that's really all there is to say about if else statements. As you use them, you'll become much more familiar with them, and you will grow to love them, because they are very, very valuable in your code, and you'll get to know that very early on. All right, so we will see you in the next video, where we're going to talk about another conditional statement, which is called the switch. Now we're going to take a look at switch statements, and switch statements are another type of control flow statement that basically evaluates a variable or a set of variables or the status of something, and then switches what is to be done based on what that is. So let's take a closer look in a playground. So a switch statement is very similar to an if-else statement in the fact that it evaluates something, and if one condition is met, it runs a certain set of code, and if another condition is met, it runs a certain set of code. And as you saw in the if-else statement example, you have the if, else if, and then else statement, which could technically go on forever if you wanted it to. You could have that meet an unlimited number of options if you needed it to, but it's a little easier to do that with a switch statement. So what we're going to do is we're going to say that we have a variable called score, and we're going to set that initially to an 85. So imagine this is a paper in school or a term paper or something, and the score was initially 85, but you're the teacher, and you're smart enough to program, so you made a little program to make things easier for yourself. So now what you're going to do is you're going to switch on the score. So you're going to evaluate the score, and you're going to open up a code block, and in here we're going to put what are called case statements, or cases for each score. So we could say in the case that it's 100, then we're going to go ahead and print that your score, oh my God, can't type. Your score was perfect. Okay, so that's in the case that it's 100. But what if it's not 100? What if it's somewhere between 90? And here's a range operator for you, the dot dot dot, somewhere between 90 and 99. Then we could do a print line and say you scored an A. Right? So notice that we're getting an error here, and the reason for this error is because switch statements have to be exhaustive. So in other words, this is an integer, so I literally have to cover in the case that this is any number imaginable, which is going to be pretty hard to do, right? So what we do in that case is we put a default case in here, and it's literally, you say default, and then what we're going to do is break, which just means when we say break, we mean go ahead and get out of the switch statement. Okay, so let's finish adding our cases there. I just wanted to show you how to get rid of that error, and the reason for that error, which is because you need to cover all your bases when you do a switch statement. Okay, so now let's say in the case that it's a 80 to 89, then we would print that they scored a B. Okay, and I'm missing one period there, that's why I'm having that error pop up. Okay, so now what it's doing is it's evaluating to the right, and it's saying that I scored a B because it's recognizing that the score itself is actually 85, and that would be the proper case to run in that particular circumstance. So we're going to make another case for 70 to 79, and in that case we're going to say they scored a C. And we'll make a case for 60 to 69. And in that case, we'll just print and say you scored a D. And then what we can do is we can make a case for 0 to 59. And we can just say that your score wasn't so good. Okay, so now if you look at this, what we have covered is if they get 100, they're going to get one thing printed out. If they get an 99 or a 90 to a 99, they're going to get an A. 80 to 89, just like you would expect. But then in the case that it's anywhere from 0 to 59, your score wasn't so good. And then the default would break out of here. So in other words, if I put this at, let's just do a couple examples. If I put it at 45, then it'll show that your score wasn't so good. But if I put it at 100, then it'll show that my score was perfect. And then what happens if I put it at 101? Nothing. You notice that nothing happened on the switch statement, but in fact something did happen, is that it evaluated that it was 101 and it went to our default case and broke out of the switch statement. Okay, so those are switch statements pretty much wrapped up, and they're very useful. You're going to find that you're going to use switch statements quite a lot, and I tend to use switch statements more than if-else statements because you can do more options in a more concise type of language. But if-else statements definitely have their purpose, and you'll see me use a lot of those. But you'll see me use switch statements whenever I can. Okay, so try to get into that habit of using switch statements because they're a great tool. Next, we're going to talk about the ternary operator, so we'll see that in the next video. In this video, we're going to talk about Swift's ternary operator, and it's a little confusing by the way it says ternary operator because it's more of a statement than an operator itself. So, but what we're going to do is we're going to take a look at it, and what it does is it allows you to write a simple if-else statement on one line. So something that generally would take about 4 lines of code, we can do in one line, and let's show you how that looks like in a playground. Okay, so as you see, I have this if statement that we worked on earlier, and it basically evaluates the temperature, and if the temperature is 32 or below, then it sets the is freezing value to true, and otherwise it sets it to false. And excluding the print line statements, that takes about 4 lines of code to do, but we can do it in one line of code, and the way we would do that is we try to redeclare the is freezing variable, and we say that that's equal to the temperature, which is what we're evaluating, which is going to be less than or equal to 32, and question mark. If that's the case, then we'll set it to true, and colon, otherwise we'll set it to false. So that one line, although at the very first time you look at it, it may seem a little confusing, that one line does exactly what this whole if statement does, with the exception of printing those lines, because you don't see me print those lines. I'm just setting the is freezing variable. Okay, so it can be useful. Will you see me use this a lot in practice? Not really, because it's not as readable, and as someone who teaches code, I like to have the emphasis on readability rather than short code. Even though short code is nice, readability is much better when it comes to the coding world, in my opinion. So as you'll see right now, it's evaluating to false just like this is, but if I set this to 23, then it'll evaluate to true on both the if statement and on the ternary statement. Okay, so pretty simple stuff. We can also set a variable based on it, and as you're declaring it. So I could say var statement, and I need to declare this as a string, and then I could say equals temp less than or equal to 32, and if that's the case, then my string is going to be it's freezing, and then otherwise it's going to be it's not so cold. So you'll see right now it's evaluating to it's freezing, and if I set it to something above freezing, like a nice balmy 89, then you'll see that it's not so cold. So a couple of different ways to use this. This is actually, if you look on line 20, this statement is actually pretty cool because it's like a property observer, and I'm going to show you what a property observer using a getter and a setter is a little bit later, but it is pretty neat line of code. It does do a lot in a very little bit of space, but readability does come into question. Now, if you can grasp this, great, you can use it in your code, but just keep in mind it's only good for either or situations. So it's only good for a if-else statement that literally has an if and an else, not an if-else statement, and definitely not something that would be more complicated like a switch statement. So, but that's with ternary operator. It can be useful at times for you when you're doing your own code, and just weigh the possibility of whether it's readable or not. Okay, and that's it on the ternary operator. In these next few videos, we're going to go over collection types in Swift, and there are in fact 3 collection types. They are arrays, dictionaries, and sets. And I also like to include tuples in as a collection type because although they're not technically classified as a collection type, they act as a collection type. So we're going to go over those, and we're going to start with arrays. So we're going to jump into a playground and take a look at arrays in a little bit more detail. So arrays are perhaps the number one collection type for just about every programming language. And what do I mean by collection type? Well, so far we've been dealing with variables that hold one single value. So to hold a string or to hold a number or anything else really. But now we're talking about collection types, and like I said, we're going to start with arrays. And arrays are an indexed type of collection, which means that when you put something into an array, it returns the array as you put it in the order that you put it in. And let me show you an example here. So I'm going to say let names, and I'm going to let that equal, and in order to start an array, you do the square bracket and you end with the square bracket, and inside the array you put the items that you want. So this is going to be an array of strings, and it's going to have my name, and then I'm going to put Christina, and I'll put Lenny. Okay, so now this is a collection of 3 names, which we refer to as an array, and specifically it's a string array because it has all strings in it. Now, one thing to note about arrays and the way they operate is that once you specify the first item as a string, then the rest of the items also must be strings. So we can't mix and match. We can't have Jason and then the number 2 and then Lenny. It has to be, Jason and then Christina and then Lenny. They all have to be strings. Now let me show you how this is indexed, because it's in zero-base index rather. So the index goes something like this. For Jason, that would be at index 0, because these are zero-base index. Christina would be at index 1, and Lenny would be at index 2. Okay, so that's how it's indexed, and that's in fact how you go ahead and pull something out of an array. So if I wanted to pull Christina's name out of the array, well, she's in slot number 2 or index 1, so I would say names, and then in order to go ahead and grab that, I would put a square bracket, put the number 2, and put another square bracket, and then, I mean the number 1 for Christina rather, and it would say on the right hand side what the value of that is on the right. So what I created there when I said let names equal and then those 3 names, that was called a array literal, and the reason it's called an array literal is because I specified what's in the array at the time that I created the array. So in other words, let me show you one way that we could create an empty array. So if I create a variable and I call that empty array, and then what I would do is I would say that's going to be of the type string array. So that's just the string value inside of the array brackets, and then I would set that equal to an empty array. Okay, so this is how you create a array that doesn't have anything in it. Okay, now I could also create an array in a different way, and we create an array called dog names here, and we're going to set that equal to, and we'll say an array of strings, and then we'll use these parentheses to go ahead and activate that array. So you see the empty array and dog names array on the right hand side are simply empty arrays. Okay, now suppose I wanted to go ahead and refer to that names array again, and I'll just type in names here. So on the right hand side we have a clear reminder of what's in there. Now let's say I didn't want Lenny in there, then all I would have to do is say names dot remove last, and that would remove Lenny from the array. And then if I pull up names again, you'll see on the right hand side that, what's my error here? Oh yes, when I created that, I created it as a constant, so let me change that to a variable so we can modify it. So then you see where I say remove last, and that takes Lenny out of there, and then the names array simply has Jason and Christina, basically the way it's supposed to be. So now we've seen how to create an array literal, we've seen how to create an empty array, and we've seen how to remove something from the last area of an array. Now let's just say that we wanted to know how many items were in the names array. We would just type names.count, and on the right hand side it would tell me how many items are in there. Now there's only 2, but if we do dog names.count, that would be 0. So how do we add something to an array? Well, it's actually pretty simple. There's a couple ways to do it actually. The first way we could do is we could call up the array, and then we could say dot append, and the new name that we're going to put in there, we could say Mikey. Okay, so there we have the array, and if you look on the right hand side, it shows the array has just the one item in there, which is Mikey. Okay, so we could also add to this array by saying the array name and then going plus equals and then adding basically a couple array items, like I'll say Latte and Bianca, which are 2 dog names. So now if you look on the right hand side, you'll see that the dog names array has 3 items in it, and it's Mikey, Latte, and Bianca. Okay, so let's say now we wanted to, and I don't want to get too much into this, but if we wanted to go ahead and cycle through the items in an array, we could do a for loop where we cycle through the names in the array, and we could just say for, and we make up a name like name in names, and then every time it comes up with the word name, goes through that, every time it iterates through that, what we're going to do is we're just going to print the variable that we just created, name, and you'll see that it does it 2 times on the right hand side because there's 2 items in there. And if I hit this eyeball, or it's coming up where you can't see it, so if I hit this, you'll see that it has Christina, and there used to be a way to show the the entire thing, but now I guess it just shows one. So, but it also shows JSON in there as well. So basically that's how you do that. But don't worry about the for syntax, because we're going to get into for loops and for in loops and repeat loops and whatnot later. Okay, but that's arrays, and arrays are actually they're pretty simple. So as you see, it's easy to go ahead and add something to an array. It's easy to remove something from an array, and it's easy to get something directly from an array based on its indexed location. Okay, now, and keep in mind that arrays, when returned, are returned in the way that they were put in. So when you put something in index 0, it stays in index 0 until it's removed. Okay, so that's going to be it on arrays. Next, we're going to take a look at dictionaries. In this video, we're going to talk about another collection type in Swift, and that is the dictionary. Now, dictionaries are somewhat similar to arrays in the way that they look, but they are very different in the way they store values. So in other words, they use a key value pair, and let me show you what that's all about. We'll jump over into a playground right now. So with dictionaries, you have a key and a value, and I'm going to demonstrate that by creating an empty dictionary. So I'm going to call this items, and I'm going to make that of the type string string. So string and string, and I'm going to set that equal to an empty dictionary. Okay, so you see on the right hand side there that it shows that I have an empty dictionary now. Now the more common way that this would be done would be, I'll just create another variable just called items2. The more common way it would be done to create an empty one would be to say items2 is equal to a string dictionary, and then use parentheses to go ahead and activate that dictionary. But you see on the right hand side there's absolutely no difference on the output. So either way you decide to do that, that's fine. Now the thing about dictionaries are, once you create them, then they need to stay the way they are in regards to the setup of the key and the value pair coding types. So let me explain what that means. So I'm going to create another dictionary. I'm going to call that products. I'm going to set that equal to, and I'm just going to create this array here. So I'm going to make a key of 123 and a string of, we'll say apples here. So there's an item in our products array called apples, and it has a key associated with it of 123. And if I make another one, so we'll say 234, and that is we'll say bananas, then you'll see that it adds bananas to the dictionary as well. Now, as I said, once I added that 123 here, I can't go ahead and say that this is 123.2, because 123 is an integer, so this needs to be an integer. This is a string on the value, so this value needs to be a string. Now notice on the right hand side here that even though I put it in as 123 first and 234 second, it's returning it backwards, and it just happens to be backwards because there's only two values. But in fact, a dictionary, when you call upon it, doesn't return it in any order at all. It just returns it in some kind of random order that it just picked up first when it went into the memory, and that's really it. So if I have this products array and I want to add a new product to it, I would just say products, and then I would go into the key, and this will go into the key 345, and we'll set that equal to oranges. Okay, so now that's oranges, but if we go ahead and we type in our products array again, or not array, but our products dictionary, then you'll see here that we have 3 items in there. So it's 234 bananas, 345 oranges, and 123 apples. And that's a typical use of a dictionary. This would be basically, if you were storing SKU numbers versus items that you sold, that would be a good way to do it. So what I'm going to do now is I'm going to create a string dictionary, and I'm going to just copy and paste this because we can save a little time that way. So I've created a dictionary called states that uses the abbreviation as the key, as a string, and uses the long name as the value. So you see we have New York, New Jersey, New York, Pennsylvania, and California. And that's all well and good, but let's say that we realize that Pennsylvania isn't technically called Pennsylvania, it's technically called the Commonwealth of Pennsylvania. So we could say states dot update value, and the value is the actual value. So that would be the Commonwealth of Pennsylvania. And that would be for the key. You need to know the key of PA. Now, notice now when we call up states that it says Commonwealth of Pennsylvania there. Okay. Now, we can also just pull up any of them. So let's say I wanted to get the value that's associated with the abbreviation NY. Then on the right hand side it would just tell me that that's New York. Now, one other thing you can do also with dictionaries is get the count, so you can understand how many items are in a certain dictionary. So if I say states.count, then we'll get 4. And then how do you remove something from a dictionary? Let's say I wanted to remove Pennsylvania completely. Then what I would do is I would say states, and I would go into the key of PA, and I would set that equal to nil. Now, if you're coming from Objective-C, nil in Swift is not anything like a nil pointer or anything. Nil literally means nothing. So now that I've set the key of PA to nil, I've set the value of the key of PA to nil. That doesn't mean that PA still exists in there. In fact, it's completely gone. So if I just type in states again just to prove this, you'll see that PA just simply no longer exists in there. So it didn't just set the key or the value of the key to nil, it removed the value and the key completely. Now, one other thing I want to show you, and this will finish up with states, is, and I know we didn't get into for loops, but one thing that we can do with here is we can iterate through a dictionary like we can iterate through an array using a for loop. So if I say for, and then I make a tuple, and I'm just going to say this is abbreviation and state, oops, and I say in states, and then what I can do is every time that goes through I can do a print line that says abbreviation, and this is how we pull out a variable. You see there's 3 characters, and then I would put abbreviation in there and say is short for, and then I would pull out state, and you'll see that that's doing that 3 times. And what it's doing is, hopefully it'll let me show you here, it's saying, for example, New Jersey is short, NJ is short for New Jersey, and it's doing that 3 times. We just can't see the 3rd time or the 2nd time. We're only seeing one iteration of it. But this here, where we call out a variable within a string, is called string interpolation. And you'll see this used quite a bit. This is very, very commonly used. And there's also something called string concatenation, which uses a plus symbol and spaces and things like that. And I think concatenation is a little less readable than interpolation. So we're going to use interpolation, and don't worry about the term interpolation, because when we use it, we're not going to say, now we're going to interpolate. We're just going to go ahead and do it. So don't worry about that too much, and don't worry about this for statement too much. But I just want to show you that this here what we made here is what we're going to talk about in a little while, and that's called a tuple. So I quickly made that tuple with two temporary variables so that I could make this print line within this for loop. Okay, so that's going to be it on dictionaries for the moment, and what we're going to do next is talk about sets. So I'll see you in that video. Now we're going to talk about sets, and sets are the third and final official collection type that Apple has put into Swift. And we didn't originally have sets in Swift when it was originally released. Sets came with version 1.2, but sets are nothing new to programming. They've been in Objective-C forever, and they've been in plenty of other programming language as well. So let's take a look at sets and see what makes them unique from arrays and dictionaries. So sets basically are an array of items, and they're so similar to arrays, in fact, that when you create a set, you need to declare that it is a set. Otherwise, the Swift compiler will infer it as an array. That's how closely together they are. So I'm going to show you real quickly how to create an empty set. And the syntax for this is a little bit different. So if I say variable teams, and I'm going to make that of the type set, and then I'm going to have that be a set of strings. Okay, that's how we actually go ahead and create, don't need that, that's how we actually go ahead and create an empty set. Okay, so, but to create a set literal, and I'm going to create something that we all have, and it's going to be called my bills, and I need to specify this is going to be a set. And the reason is, when I say equals here, I start out with these two square brackets, and inside here is where I put my information for my set. So this is going to be a set of strings, and as soon as I say that it's a set of strings, that means that it must contain all strings. So one of my bills is going to be electricity. Okay, and then another bill would be my cell phone, and another, whoops, I don't know how I got there. Another bill would be water. Wow. And then let's say I have to also pay for my internet access, right? And then let's say I mess up and I put water in there again. This is what makes sets special. You see how I have water in there twice. But if we look to the right here, water is only in there once. And the reason for that is that everything in a set must be unique. So if I have water in there once and I try to put water in there again, it won't take it. It will allow you to do it, but it won't do it on your return. So keep that in mind, and that's what sets are really useful for. So if you have a set and you want to or if you have a set of data and you want to make sure that all the values are unique, let's say you had account numbers or vehicle identification numbers or something like that, and you wanted to make sure you didn't accidentally enter the same one twice, then a set would be ideal for that, because you could literally enter it the second time, but it wouldn't show you that it's entered in there. Okay, so now just like with arrays, you can say mybills.count to find out how many items are in there, and you'll see that it says 4 items. Now note that we have entered 5 items, but since water is only being shown once, it's only going to count it as one thing. So how do we add to a set? Adding to a set is actually pretty simple. You just type the set name in, and then you say insert, and you put a new bill in there. So we could say that one of our bills is car insurance, right? Okay, so, and then let's say we wanted to remove electricity because now our landlord pays for our electricity. We could say my bills dot remove, and we could type in electricity, and it would remove electricity. Okay, So now we could just go ahead and see what my bills looks like. So we have cell phone, internet, water, car insurance, and notice that sets don't return in order. So here it's saying cell phone, internet, but technically it should be saying cell phone, water, internet, and it's not. So they don't return in any order. That sets them apart from arrays as well. So difference between sets and arrays, their syntax is exactly the same, but they act a bit differently. They don't return in order. They're not in an indexed. They're not in an indexed location, so they don't return in any order, and they must be unique values. Now, one cool thing about sets, and you can do this with arrays as well, but I think it's neat because these are my bills, and I can say remove all, and then I have no bills, which is perfect for me because I love that. Another way to actually do the same exact thing would be to say my bills and just set that equal to an empty set. Okay. Now I don't have to declare that that's a set there when I set it equal to an empty set because my bills is already a set. So now we would just go ahead and do whatever we normally would. One thing I want to point out, and this has nothing to do with sets, but I don't think I mentioned it in the course so far, is you see where I'm writing my bills and I have the B capitalized because that's a new word. Well, variables start with a lowercase letter, so whatever the first word is, it's all lowercase, and then when a second or subsequent word pops up, you would say, you would capitalize it, and this is called camel case. So if I just create a regular variable and I call that my dog name, this is how it should be done. And and I would set that just equal to my dog's name. Okay, so but that's how it should be done, camel case. And there are cases where this should be capitalized in the front, like classes, structures, enumerations, things like that, but we'll get into those details as well. But I just wanted to point that out to you because it just occurred to me that I hadn't pointed out camel case to you before, and you've probably seen me doing it this way and wondered if that was a normal convention, and that is indeed the expected convention in programming in Swift. Okay, so that's going to be it on sets actually, and what we're going to do now is we're going to look at the unofficial collection type, which is a tuple. Okay, now we're going to talk about tuples, and tuples are not officially a collection type, but they act so similar to a collection type that I decided to include them here. Swift language just recognizes a tuple as a type, not a collection type, but they are in fact a collection type, and I'll show you what I mean by that when we hop into the playground. Now don't get hung up on whether it's tuple or tuple. Just say it however it sounds normal to you. For me, I've just been calling them tuples ever since I've been using them. So they're they're not specific to the Swift language. They're also in other languages. So I've always called them tuples, and we're going to see what they're all about right now when we jump into a playground. Okay, so on the screen we're looking at a product index, which is a dictionary, and it's a integer string dictionary. And this is the nice thing about tuples. Now this is the actual tuple here, and you've seen something similar to this when I talked about dictionaries. I showed you an example of a tuple in a for loop with the states, if you recall. So this time we're just doing it with the SKU and the product, and the nice thing about this is that the SKU can be an integer while the product can be a string, and everything will work out right. So if I go ahead and I look at what this is returning, it says the SKU for pairs is 967, and it's doing that 4 times, but we can only see the 1. But that's the really cool thing about tuples, is that they can contain multiple value types in one tuple. So using a tuple to iterate through a dictionary is something that's very common, and something that's not as common but it probably should be is to just go ahead and create a tuple. So if I were to say let tuple 1 and I say equal, Now to create a tuple, we got to go in parentheses, and I'll say that one value is going to be my name. I'll make another value my age, and then I'll make another value just $12.99 just for the heck of it, and then I'll say true. So if you look here, we have values that are a string, an integer, a double, and a boolean, and they're all okay being in that tuple. Now, interestingly, if you look to the right here, you'll see that 0.0 is JSON, 0.1 is 40, 0.2 is $12.99, and that's how you access those values out of tuple 1. So now tuple 1 actually has all those values. So if I say tuple 1.0, then that will give me JSON. But if I say tuple 1.3, then that'll give me true. So it's just another way to get things out of that tuple and to show us that information. Now, one really common use for a tuple is when you have a function that returns more than one value type. You would return it as a tuple. So I know we haven't gone over functions yet, but I like to get you in the mode of seeing things beforehand, because we really haven't gone over for loops yet either. So to create a function, we use the func keyword, and then we name it. And then in here, we would put any types that would come into it, and then we put this arrow looking syntax in there, and then we say what we're going to return. So in here, I'm going to return a string, an integer, and a boolean. And then I just open up my function block, the block for the function. And here, I'm just literally just going to set some variables. So I'm going to say let name equal Viper. I'll let speed equal 165, and I will let is convertible equal true, and then we need to return those values. So we're going to return name, speed, and is convertible. Okay. Now what we can do is we could set the car to have those values. So we could say variable car is equal to get car details, and now we'll be able to access that using the car and dot notation. So car dot 1 or 0 will give us the name. Car dot 2 will give us the value of whether it's convertible or not. So we have Viper and it's convertible. Now the other thing that we could do is we could create, since we have that function there, we could create something like this. We could say let, and we'll make a tuple, and we'll make our own names. So the name, the miles per hour, and the top, and we'll set that equal to get car details. I'll just make a little room here, and then when we call up name, you'll see that it shows Viper and miles per hour and then top, and it shows all those values that we got out of there. And that's really what the main use case is. You'll see these a lot on completion handlers in functions, and I know you're not familiar with what that is, but you will see this a lot in what's called a completion handler in a function, and you will see this a lot, in any function that returns multiple value types. They will be they're kind of forced to use a tuple, or not necessarily forced to use a tuple, but that's the best case scenario, is to use a tuple when you're doing something like that, because as you see, you have all this functionality. So now, with this information, I could do a print line, and I could dynamically pull out these values. So I could say the name goes at least and then I'll pull out the miles per hour, and I'll say miles per hour. So the Viper goes at least 165 miles per hour. So you can see how useful tuples can be, and I'm not going to spend much more time on them, but they are important to understand because you will see tuples quite a bit in the code as you're working with different frameworks. Okay, so just keep that in the back of your head that tuples are going to be there for you, and we're going to go over tuples again when we go over through loops, but I just want to have you see this at least once now, and then you're going to see it again when we do functions probably. And then, this way it kind of gets ingrained and it kind of becomes second nature to you. All right. So tuples, excellent collection type. They can use multiple value types, and they're not officially a collection type, but as you see, they work just like a collection. All right. So we'll see you in the next video. Now we're going to switch gears and we're going to take a look at loops. And there's three kinds of loops. There's a for loop and a for in loop. There's a while loop, and there's a repeat loop. And don't get confused if you're not familiar with what the repeat loop is, because the repeat loop is basically what replaced the do while loop. Okay, so there's still only three types of loops, and we're going to start off with the for and the for in loop right now in Playground. Okay, so if you've ever programmed, then you're probably familiar with what a for loop is. And the first for loop I'm going to show you is where we declare the variable and set its value, and then we go off of that. And it has three sections, and this is more than likely the for loop that you're most familiar with if you are coming from a coding background. So what we do is we say for var, and we create a variable. In this case, I'm going to create a variable called I, and I'm going to set that equal to 1. And then we put a semicolon. And then we say under what circumstances do we want to evaluate it. So I'm going to say if I is less than or equal to 10, then I want to go ahead and evaluate that. And I could leave it like that, but I'm going to just space it out so it looks correct. And then we want to say how we want to increment I. So in this case, we're going to take I and we're going to go plus plus. And plus plus just means add 1 to it. It's shorthand for I plus I, basically. So, and then all we're going to do in this case, as we go through this loop, is we're going to print a statement, and we're going to say that I equals, and we'll pull out the value of I. Okay? And you'll see that it goes through that loop 10 times. And to give you an idea of what that shows, it would say I equals 10. So the last time it goes through, it's going to say I equals 10, because at that point it's equal to 10, but once it goes one more, it's no longer less than or equal to 10, so it stops. Okay, so that's your basic for loop. And then for a for in loop, you need to have something to go ahead and loop through. So what I'm going to do is I'm going to create an array real quick, and I'm going to say let names equal, and I'm just going to create an array of names. So I'll say my name, Ravali, and Barnali, and of course Christina. So now what we want to do, now that we have that, is we want to loop through that, and we want to, let's say we want to go ahead and print the names. So for a for in loop, you say for, and then you create a variable, and it could be anything. You could name it n, you could name it name, which I'll do now because this makes the most sense. So I'll say for name in names array. Then what we want to do is open the code block, and all we want to do is go ahead and print the name is, and then we'll pull out the name dynamically for that variable that we created. So you'll see that that goes through 4 times, and the reason it's 4 times is because there's 4 names in there. So if we look at that, says the name is Christina, so let me just put a period here to make that look a little bit better. So it says the name is Christina. Okay, now the only thing else I want to show you here about for in loops is going through a dictionary. So first we want to create a dictionary. So I'm going to say let inventory equal, and we're just going to make a dictionary literal here. So we'll say 1, and that'll be TV, and then we'll say 2, and that'll be radio, then we'll say 3, and that'll be newspaper. So I should have probably made that media types or something, but you get the point. So then what we would do is we would do a for in loop using a tuple. So we would say for, and we'll just say index because they're numbered, and then item in inventory, and we're going to loop through that, and we're going to go ahead and now, you know, what we're going to do is we're going to print out a value. Now normally you would do something additional than printing out a value, but we could say item and then pull out the index, is a, and then pull out the item. So you'll see that on the right hand side it does that 3 times. And if we go ahead and take a look at one of them, it says item 1 is a TV. Okay, and it would say item 2 is a radio, item 3 is a newspaper. Okay, so for loops, very useful. I'm actually going to use this same playground to go through our while loops and our repeat loops, so you have reference to them all in one spot. So I'm just going to create some room down here, and the next thing we're going to be talking about is going to be the while loop. So I'll just put a comment there, and when we come back in the next video, that's exactly what we're going to do. We're going to talk about the while loop. Okay. In this video, we're going to continue our discussion on loops, and we're going to go into the while loop. So we're just going to jump back into that same playground that we had open for loops. So a while loop runs, as you might expect, while a certain condition is met. So basically, in order to use a while loop, we need to have a variable set. So I'm going to set variable x equal to 0. And then what we can say is while x is less than or equal to 10, then we open our code block, and just move that up so we can see here. Then what we would do is we got to do 2 things in here. First, we want to run some code, and then we want to increment x. Okay, and I usually increment x first, because if you don't, what you'll end up getting is a never-ending loop, because if you don't increment x, it'll always be 0, and it will continue to run and run and run until the memory on your machine runs out and it finally crashes, or the memory on the device runs out and the device crashes. So in this case, we're just going to go ahead and print the value of x. Okay, so it does that 11 times, and that's because it's starting at 0. Okay, but what if we want to do something a little bit more interesting? And we already have the method to do that here because we have a names array up here. So we could say while x is less than or equal to names.count, and that would pull out the count of those names. Then we could go ahead and do something in there. We could print, instead of printing that, we would print, so we would still print that, but we would print names, and then we would go into there and put the value of x in there, and it would print that out. And what am I getting an error in there for? Let's see. Now, it should be no problem, but I don't really know why. Maybe we need to just interpolate this a little bit. This is 5 times. Let's see what we got. Names x, yeah. So let's just, we'll do an interpolation on this. And now we should get the correct. No, it's still not letting me do that. So it's not letting me do that for whatever reason. I think this is an error in the playground because this code should work without these. It should work just like this. And it's not. Oh, we got one extra in there. It's still not working. But the whole idea is that we could do something. So let's just print out the value of x in here again. But really, we should be able to pull the name out of there by going into that array. And it's just not letting me in this playground for whatever reason. So 5 times, it's just going to print out the number. So, you know, it goes up to 4. So 0 through 4 is 5. All right. But that was really just to show you that we don't have to go by a specific number. We can go by a number that's, you know, dynamically changing, like the array of names. You could have names being added, you know, to your array every couple seconds, and this while loop would still run, and it would change, and it would do whatever code you have in here to go ahead and do. Okay, so really that's all on while loops. And next we're going to take a look at the repeat while loop, which is very similar to the while loop, and we'll go over the difference in the next video. Now we're going to take a look at repeat loops, and repeat loops are very similar to while loops with one subtle, or actually one major difference. And in addition, I also did figure out that error we encountered in the last video, and I fixed that, so I'll show you that as soon as we hop back over to the playground. Okay, so that error was occurring because I had an equal sign in here, and we need to have it just say less than names.count, because the count is always going to be one more than the index. So it encountered an error when it got to names.count, and it tried to pull out the index at, let's see how many there are, the index 3. When it tried to pull out index 4, it encountered an error. So we need to just have that as less than, and then this works as expected if we take a look at it. Not that way, but if we take a look at, well, it's not showing, it's not letting me show. Oh, I'm looking at the increment, sorry. It just prints out the name there, so it pulls the name out of the array. So it's going into the array and pulling the name out at the array where the value is x, which is within the names.count. So it pulls out a valid name every time. Okay, so let's just close that up. And now we're going to take a look at the repeat loop. And the repeat loop is very similar to the while loop. And basically what we do is, because I have x set at 0 already, we can just go ahead and repeat based on x. So we do a repeat loop by starting it with the word repeat, and then we immediately open up a code block, and then this is where we put the code to run, and then this is where we increment x in this case. And then after this, we're going to say while x is less than or equal to 100. Okay, so what we're going to do on the incrementer is we're going to go ahead and we're just going to say x plus plus, and I don't want a big X, I just want a regular X. So let's say x plus plus, and then the code to run, we're just going to go ahead and print. Now it's only running 97 times because the variable x has already been modified by our while loop above. Okay, so don't let that throw you off. But you know, if I had commented out that while loop, it would run you know, 100 times. So what we want to do here is we're just going to print the value of x, and you'll see as that just does it 97 times because we're already at 4, so it would do 101 from 0 to 100 normally. Okay, so basically the difference between a while loop and a repeat while loop is that the repeat while loop will run no matter what. Notice there's no check of anything before this runs, and then it says while x is less than 100. So x could be 130. So as a matter of fact, let's make x 130. for right now, and I'll just comment out this while loop. And a quick way to comment things out is to just highlight it, and then press Command ? Okay, and it repeats that while loop out. All right, so now you'll see that even though it's 130, it goes ahead and prints out 130 here, but that's while x is less than 100, so it's only running one time. So if I go ahead and make x 1 again, or 0, then it will print out, the correct amount of times, and it's just printing out the value of x. Okay, so really that's it. I mean, I'm going to leave all this in here for you so you can look at all the loops and differences between them. Basically a for loop, you create the variable, you set it, and you give it a value, and then you set the amount where you want to evaluate it. So in this case, while I is less than or equal to 10, then you set your incrementer or decrementer. Mind you, this could be a decrementer, could be minus, but that's not going to be good because you see on the right hand side that just keeps running and running. So let's just make that an incrementer again. And as soon as my playground gets back to normal, you see that's what I was talking about when you have infinite loops. But minus is, short code for -1, and plus is short code for +1. All right, and then we just do whatever we want to run in this loop. Now the for in loop is a little bit different. We say for, and we create a variable, and we say in the names array, and then we're going to print the name is name, and you see that runs 4 times. And then if we do it through a dictionary, then we put a tuple here to go through those items in the inventory, and we print those values out. Now the while loop I had commented out, but I believe I can uncomment this because, and to uncomment it, you just do the same thing, highlight it and press Command ? Now it's going to do this 3 times, but it does increment x also, so that affects our code down here, but it doesn't really matter. So hopefully you can see the difference between these loops and understand where they may come in handy. And all of them do have their place in code. I must say that I've used every single one of them, and I don't necessarily use one more than the other. Well, I probably use for name in names, or for tuple in whatever, more often than anything. But you will use while loops, and you will use repeat loops. So it's good to know all of them, and this is just a handy reference sheet for it. Okay, so next we're going to move on to functions, and functions are going to be pretty exciting because functions are going to be the first time we're actually going to be able to do something with our code aside from direct the flow or print out a value that already exists. Okay, so functions are something that actually do something with our code, and we're going to take a look at that next.